first off, I just wanted to send out a quick thank you to those of you who are joining us from our 24-hour channel. Lovely place where members are able to watch and control our live telescopes from both the Canary Islands and Chile every night when we have clear weather. Pretty great gig. Now, today, we are talking about the lost asteroid, asteroid 2013 TX68. And this is not a graphing calculator. This is an asteroid. So we sort of like to call it the B2 bomber because it is estimated to be about the size of one of those stealth bombers. This asteroid was first discovered, and we were able to use actually old measurements from the time when it previously was on the close approach to estimate the date of the close approach that we just recently witnessed. Still, even so, nobody was able to find it again until very recently. It had been lost, the lost asteroid. That is until a couple of days ago when somebody was finally able to capture a glimpse of it once again, making this asteroid found where it had been lost. It was returned to us, at least it has been for the time being. And today we're going to talk about this, like how we possibly find an asteroid, then we lose an asteroid. How does that work? Why does that happen? And why some asteroids are potentially harder to find than others. As we talk about these different things, we'll take sort of a look, a perspective about what we could or should do about all of this. Where is sort of the human ingenuity going to fall in this situation? And so if you have any questions or comments about this show, we love to hear from you all the time. You can send us a tweet at Slooh, or you can use our brand new chat room if you're looking in the on the Slooh website and you're watching this show there. Depending on your browser, it will either be to the right of the show or you scroll a little bit down and it'll be right there underneath the show. And we'll be checking those throughout the show to see what you're talking about, and maybe we can answer some of your questions. We'll try to answer as many of them as we can on the show. But now, I am joined today by Dr. Today. So thank you so much for joining us, Dr. Boslough.
My pleasure. Thanks for having me.
It's so great to have you on. And so just to sort of to start off, I was wondering if we could maybe talk a little bit about the basics of this asteroid. What sort of fundamentals do we know about it? Like how big it is? Do we know how fast it's moving? Do we know sort of what it might be made of?
Well, pretty much everything I know I got from the Jet Propulsion Lab website. They basically have all the information that is known about this asteroid on the website. And what we know about it is that the size is fairly uncertain. It could be as small as 20 meters or as big as 50 meters in diameter, roughly in round numbers. So that's uncertain. And the orbit is very, very certain, but the position in its orbit is not so certain. So we do know for a fact that the orbit does not intersect the Earth's orbit, so there's zero probability that it'll hit the Earth. But because the position along that orbit isn't known, we don't know exactly when it did or will pass the Earth, and therefore we don't know the distance by which it'll pass the Earth. So it's no threat at all to the Earth, but it's big enough to be a minor threat. It would be similar to the asteroid that exploded over the city of Chelyabinsk, Russia, 3 years ago.
And so you were mentioning that we don't quite know where it is along this orbit. And so do you know a little bit about what exactly makes it so difficult to track, or asteroids like these? Like why do we have these uncertainties in the orbit?
Well, when this was first discovered in October of 2013, there were only 3 days between when it was discovered, between when it first came into view. Remember, it's a very small object, so it's very dim, and it was in the night sky, but it was approaching the Earth from the outside. So it was away on the side of the Earth, away from the sun, in the night sky, but it was crossing Earth's orbit, and then it crossed into the daytime sky, and it got between the Earth and the sun. So there were only 3 days between there was a found, and that gave a longer observation. A longer observation.
Common to lose asteroids? Common to lose asteroids?
To resolve the position in years in advance is high, and the Earth can actually be within that uncertainty, and that's typical. So there's always a very small impact was in the mid-Atlantic, but it could have been anywhere along an arc of uncertainty across the surface of the Earth.
And so we have a bit of uncertainty sometimes with impact. And so if there was the possibility that this B2Bomber-esque asteroid were to impact the Earth, you were mentioning sort of a similarity to Chelyabinsk. Is that probably sort of the amount of severity we would expect from this type of asteroid?
Yeah, if an asteroid of that size, of course, the size is also uncertain. It could be as small as the asteroid that exploded over Chelyabinsk, in which case the effects would be very similar. Or it could be as large as the object that exploded in 1908, also at Tunguska, and that was a much larger explosion by a factor in, and so it exploded at high altitude. It was smaller and came in at a shallow angle. Tunguska came in steeper and was bigger, and so it deposited more energy on the surface, and that's why all those trees were blown over. So an object of this size could be as big as the Tunguska asteroid, but there are lots and lots of those objects. In fact, there are about 1 million of those. And in fact, I and a colleague estimated the number of objects that are probably closer to the Earth right now, and there are thousands closer to the Earth right now than 2013 TX68.
Oh, wow. And
we don't know
so
where any of those are.
That's a little bit terrifying. I mean, it's sort of on the scale like of different sizes of asteroids. How many do we know are out there? Like, are there certain percentages of the large asteroids that we know how many that we caught track of? We know how many that we still have to look out for?
Well, we actually have a pretty good understanding of the population and the distribution of sizes, and the biggest risks are the ones greater than 1 kilometer or so in diameter. Those are the ones that it could actually do global damage. I mean, those would be a serious problem if one of those were to hit the Earth. It would very likely kill, upwards of 1 billion people. It could change the climate for some time. It could wipe out our agriculture and our ecosystems and create a long-term climate change. So those are the real hazards in terms of severity of consequences. But fortunately, we've already discovered 90 to 95% of those objects. There's about 1,000 of them. They collide with the Earth historically once every 700,000 years or so. Objects of that size are bigger. But we know of none of them that are going to hit the Earth within the next 100 years, and only 5 or 10% or so of those remain out there undiscovered. So that's where the focus has been on discovery ever since the Space Guard survey started back in the 1990s. But when you get down to the small sizes, like the Tunguska size, now we're talking about 1 million. If you get down to the Chelyabinsk size, now we're talking about upwards of 10 million. And Chelyabinsk sized objects hit the Earth, we think, every 30 to 50 years on average. But of course, they usually don't collide over a city. Usually they're out over the ocean. 2/3 of the Earth is ocean, or they're out over a desert, or they're out over an unpopulated area. So the risk is limited when you talk about Chelyabinsk-sized objects. And even, Chelyabinsk itself, it could have been catastrophic if it had come